Hi, friends. It's Ben again. I wanted to try to make you all a video that give you maybe some encouragement about how to get started with doing some programming and such. I probably, full disclosure, should say that I've been producing a lot of these videos over the past year, and maybe I'm having withdrawal symptoms from them or something like that. I don't know. But I thought maybe showing you all that I do some programming as well, and that, sometimes I come in and just try to do the best I can as well. Maybe that might be a little bit encouraging. If it's not, let me know, and I'll try not to do things that are along those lines as much. In any case, though, so I'm going to try writing a couple of little programs here and show you what I'm doing. So unfortunately, this will be a YouTube video of you watching me program, which doesn't sound like it's very exciting, but it might give you some ideas about how to get started, and just that sort of encouragement of you try something. If it doesn't work, it doesn't work. So in any case, the thing that I'm looking to share with you all is just this little bitty project that I have in mind of trying to figure out how much something is different. Okay. So remember, I'm a math guy, but also remember I'm a huge nerd. And so the thing that I'm going to share with you is actually something from D&D. So I'm going to go ahead and bring that window up there. And I think if yeah. Okay. So hopefully you should be able to read that easily there. But in D&D, they introduced a new mechanic that's referred to as rolling advantage. So if you're not used to Dungeons and Dragons and various other games like this, we're frequently rolling dice. And with the dice roll, it determines your success or your failure on something. Usually rolling higher means succeeding. So in this, in the past, a lot of things would get you bonuses, or it would change a difficulty level or something like that. And this idea of rolling advantage is a relatively recent notion, and people like it because they get to roll more dice, and rolling dice is fun, I guess. So if you saw that description there, it said that sometimes a special ability or spell tells you that you have advantage or disadvantage on an ability check. Disadvantage, well, sorry, continue on here. Advantage or disadvantage on an ability check, a saving throw, or an attack roll. When that happens, you roll a second d20 and you make the roll, using the higher of the two rolls if you have advantage and the lower if you have disadvantage. Boom. All right. So it's a simple idea, but then if you're trying to figure out how much difference that actually makes, it may not be super obvious. So, or at least it's not obvious to me. So I'm coming along here, and you can probably see that I have my stuff in the background where I'm connected to my account. And so I'm just going to go ahead here and go over to my Google Drive account. And I want to make sure and just point out to you all how the structure of this goes. So on Google Drive, if we're here on My Drive, that's sort of the central thing. In the old days, we would have referred to that as the root, but you may not think of it in that way. These symbols that we've got along the side here are referred to as folders. And I don't know why most of my folders are gray, except for the one that says Colab Notebooks. Colab Notebooks was generated by a program rather than being generated by me, so maybe that has something to do with it. But you can see I've got bunches and bunches of folders, but then also in this My Drive, I have some PDF files and stuff like that. And up at the top, it shows me some of the recent things that I have had on here. So I'm going to go ahead and put this into my fall materials folder. And you'll notice that I have my various classes there and like syllabi and stuff that I still need to edit for other classes. But I always refer to this class as SciComp because it's not comp sci, it's SciComp. It's just kind of meant to be cute. And you'll notice I've got a bunch of notebooks already there that have like the .ipynb. So it's meant to be like a Jupyter notebook and IPYNB. So anyway, I am going to go ahead and tell it to make a new one of those. And when I say new, it gives me all these choices, and it does not give me Google, it doesn't give me a Google Colab as an option, but I can find that if I go to more. Now, if yours doesn't give that to you, you should go Google, welcome to Google Colab, and it will show you a little video. And after you've watched the little video, you can save the actual Google Colab notebook to your account, and it'll make one of those Colab notebooks folders for you. And it should, after that, let you, anytime you want to make a Colab notebook, to make a Colab notebook. Okay. Now I'm going to, up here at the top, create a text cell. Notice it didn't put that at the top, but I'll fix that in a second. And I'm just going to say determine how much better your role is when rolling advantage. Okay. And then I will click into something else, and you'll see that now it's actual text, and I can take and move that. Nope, I can't. In order to move that, I have to come over here to the arrow and move it. But in any case, when I'm in that, if I want to make another text box after it, I can click the plus text box. I think there's something over on the right that lets you do the same thing. And I'm going to say here via simulation. If you notice, there's some markup stuff where I can change the font and stuff like that. But you know, that's what I'm going to do for now. So when I say that we're going to do this via simulation first, what I mean is that you could literally just go roll dice and figure out, you know, how much better something is. But the thing that that I'm going to try to do here is to do this a bunch of times, because your long-term averages often are different than what you get for a short-term thing. I could, by chance, just roll 20s if I were, or roll all 20s for like 2 or 3 rolls in a row if I was just doing a few of them. But if I do a large number of rolls, that ought to kind of give an idea here. So first thing I'm going to do is to determine, I'm going to put this in comments here, determine average for regular rolls. Okay, so with regard to this, I'm going to need to generate some random numbers and stuff. And I don't really remember how to do that, but I'm going to try to. So since I don't remember how to do that, and I hope this will follow me over to the other tab, it doesn't want to. Okay, I'm going to tell it to stop share. And then I'm going to make another tab here where I'm going to try to do some searching. So then I should come back and share that other tab with you. All right, so we are going to ask it Python generate array random numbers. Boom. So how to generate random numbers in Python. And if you're thinking, gosh, he just picked something that was easy to find. Yeah, maybe, but maybe not. So use of randomness, blah, 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 statistics for machine learning tutorial. I don't want this. This is not what I want. I don't want to bother with a tutorial. Sorry, this may seem silly to all, but I'm hoping to just get an answer. Aha, NumPy manual. So numerical Python, I'm going to open that up and see what it's got going on here. So random.randint, low, high, size, and dtype. Okay, so when it says size equals none, I'm going to see here, size int or tuple of ints optional output shape. Okay, so I think that that's what I want to do here. So I'm going to look at their example, np random randint, and okay, so I'm going to stop share and share again in order. Okay, I'm going to have to close something. Wow, that's going to be so annoying. All right, this should be easier than what it is, but oh well. All right, so this said, what was it, NumPy randint. I'm gonna have to, God damn it. Sorry, it is super annoying that Zoom insists on putting things in the places that I need to click. Okay, so it went low to high and then size, so random.randint. Okay, so coming back here to what we were looking at, I'm going to just type here numpy.random.randint of 20, and this should give me an error. And the way I make this run is either to click on the play button or to hit Command Enter or Control Enter if you're on a Windows machine. This should give me an error. And if you read the error, it says the name NumPy is not defined. That's because we have not asked it to import. So from NumPy import random. And then hopefully from that, we can tell it to just do random.randint, and it gave us an 11. Yay, it gave us an 11. Right? That's maybe not all that big of a deal for y'all, but it did manage to generate that. Now, I would like to tell it to go 1 to 20. Hopefully y'all can see that. It popped up a little window that shows me random.randint, and it shows me what the options of the function are like. That's going to be super handy. So low to high, and then size. So we're going to go 1 to 20, and let's tell it to do 100 of them. And so I'm going to just tell it to go, and it goes and does that. Now, taking a look at what we got there, we got an array, and there's a bunch of numbers in it. And because of the fact that I've programmed in this language before, I know that there's a common thing that might happen. And I want to be able to look at those numbers there and see, did I actually get a 20? Because I think I'm going to find out that I can't get a 20. But I need to be able to manipulate it in order to do that. So I'm going to say x equals that. Notice that when I say x equals, now it doesn't print it. If I wanted it to print it, I have to tell it to print X, or I could just tell it X. So now I am going to try to ask it to tell me what the maximum of those is. Max of X. Let's see if it does it. It does. And the max it's got is 19 of them. Now, I only rolled it 100 times. Maybe just by coincidence, I happen to not get the 20 out of those. I don't know what the odds are of that. They're pretty low. But if I said do it a few million times, oops, and I hit the wrong button. I hit Control Enter, tell it to do a few million times. That may be actually telling us to do a few billion times. I'm not sure. And it's unhappy about it because I gave it a really large number. Okay, but it did it. And it only ever got a 19 for that maximum. That's because with your way these functions are set up, when you say the maximum, it will never give you that maximum, but only at maximum one less. This is super annoying, but it happens all the time in computer programming stuff. Let's check and see if the minimum is I should have reduced my number. I will do that for next time. Maybe we'll just do 1,000 of them next time. There's a way to abort those, but I don't remember what it is. So now if you notice, we did get some ones there. So great. Okay. So now we know how to do that. And because we're going to try to do some stuff with it here, we should start off with not doing very many of them. And we should also try to print what we get as we go along here. And I'm going to tell it to print the max of X and the min of X and the mean of X. I'm not entirely sure that mean is defined for it. We'll find out if it is. Oh, hang on. I said mean. When I said min, nope, it doesn't want to do that. Okay, and I'm doing a trick here where I will say with my separator to make a \n for new line, and then let's say 2 new lines on it. Okay. Now I think this is going to give me an error. The error is mean is not defined. So let's see if I can do it now. Okay. So the thing I did there is that I told it that NumPy has something called random and something else called mean that will do averages for me. So my mean that I got on this is 9.77. Notice my max is still 19. I forgot to fix that. I'm going to tell it to go from 1 to 21 so that now it will give me, oops, and after the print X, I'm going to say to put a new line after that. All right. So my average was 9.62, which is not what I expected to get out of this. Let me try to do 1,000 of them, and I'm going to comment out the line where I print those out. Actually, before I do that, let me look. Yeah, I'm getting some 20s and I'm getting some 1s. Yeah, okay. So I'm going to comment out that line where I print out the whole thing. I'm going to tell it to do that. 10.013. So I'm going to go ahead and jump this up to 100,000, which shouldn't cause too much of a problem. And when I do, I'm getting 10.53 something. Now, from theory, I know that the average should be 10.5, but my simulation, is getting it like that. Okay. So we've done a simulation there, and we can do it several times. And when we do, we're getting numbers that are all around 10.5. Okay. So then we're going to add another cell here. And in that cell, we're going to determine the average for advantage rolls. Okay. So with this, we don't need to import the random or the mean because they've already been imported. And so I'm going to say y equals random dot rand. Oh, no. First, I'm going to do this. N equals 1000. Okay. You'll find that abstracting like this is going to save you a lot of time. I'm going to say n equals 1000. That's my number of rolls that I'll do. Later, I'll come back and change that. As a matter of fact, maybe I'll start with 100. I'll come back and change that later. Okay. Because now I'm going to, for this, get y to be, I don't want to have to type that whole thing over again. I will come up here, copy that here. I don't really want to reuse my x's, but I can, yeah, whatever, because I kind of accomplished my point there before. All right, I'm going to tell it to do n of these. Come on. Both of those. And I'm going to call one of them x and one of them y. And then I'm going to tell it to print x comma tick slash n comma y, and just see what those look like. So you can see those there. And maybe I should have put them in entirely different print statements or something. I don't know. But I am going to try having it to print the max of x comma y. Okay. Now, NumPy, numerical Python, has this thing called casting, where you can take a regular function and instead of feeding it a number, you can feed it an array of numbers, and it knows to just take and apply that function to all the things in there. Okay, so let's see if this does what we expect it to. When we generate a new x and y, of course, we'll have to look separately at this. Actually, you know what I'm going to do? I am going to tell it to print x, print y, and print the max of the two. Okay, so it does these all in separate things, and it says, oh, the value of an array with more than one element is ambiguous. Use a.any or a.all. That does not do what I wanted it to do. So looks like the casting does not apply for this. And so I'm going to have to try something different. And it tells me I was signed out on a different tab and I have to sign back in. I don't know why I did that. Okay. So I am going to come along here. Max of x comma y. I'm going to generate the same error. I just want to make sure that everything's fine here. And use a.any or a.all. Okay. So I'm going to try this. And this is going to generate a different error, right? So I'm going to tell something that I want an empty array. And that error empty is not defined. And so I'm going to need to come up here to the top and say import from numpy, sorry, from num import empty. And let's see if this will work. Okay. It's okay with Z being empty of N. Okay. And now I'm going to tell it Z of everything equals max of X of everything, comma Y of everything. I don't know if this will work, but what I've told it here is to go through element by element, taking the maximum of the two things in order to see whether we can get that. And it says, no, I can't do that. Truth value of, okay, so it just does not like that. So we can still do this kind of the primitive way and say for I in range of N, Z of I equal to the max of X of I, Y of I. And then outside of that, print Z. Let's see if that does it. Okay, just looking down through here, we can just compare elements. 13 and 2 got us 13. 15 and 15, I'm sorry, 15 and 10 got us 15. 20 and 9 got us 20. So yeah, it looks like it did. All right. So now that we've got that bit, we don't really need the print portions of it. What we're going to really want to do, oh, and by the way, notice I didn't just delete stuff. I went ahead and commented it out. And the reason for that is that I might want to come back and use that later, and I just don't want to have to redo that typing. So we are going to print the mean of Z. Okay, remember that earlier we figured out that the average for just straight rolling is around 10.5. And so we're doing that for this mean of Z. We're getting 14.29. Could just be a fluke though, right? So how big do we make our number of rolls before? 1, 2, 3, we did 100,000. So let's do that again. And so we're getting a mean of about 13.8. Okay. And if we do that a few times, seeing 13.8 something. All right. So it's looking like the difference is around 3.3. Okay. So that is doing this with a simulation, which is how people accomplish a large amount of things, but it's not really mathing it up just yet. So I'm going to add a text thing here because I said we're doing it via simulation the first time. And this time we're doing it via the theory. Okay. So if you were to roll 20-sided dice, you have 20 possibilities that could happen. And if you have 2 of them, when you roll, there's 400 ways that that could come out. So we're just going to do that. Take and roll 400 dice, except we're not going to roll 400 dice. We're just going to look at all the possibilities. So we're going to come along here and say, enumerate all possibilities from 1 to 20 for each roll. Okay, so what we will do is come along here and say 4x in range parentheses 21. No, it can't say just 21 because that will start at 0 by default. So like with the simulation, we're going to say 1 to 21. Okay. And then inside this, we're going to say for y in range 1 to 21. Okay. And then in here, we'll say z equals max of x comma y. All right. And notice that now with these two loops, we're going to go through 1 through 20 with all the possibilities on both things, but getting then that max inside of there. Now we need to figure out a mean, but we don't really have a place to put it because z is going to get overwritten every time here. So what I'm going to do is to say L equals that. That should make an empty list, okay? And L looks too much like a 1, so I'm going to use a capital L for list. And it's tried to give me something there, but I think I'm okay. All right. So then L dot append z. Okay. And then when we get down to the end there, let's print L. And let's see what we end up with on this. Okay. And mostly at this point, I just want to see that it actually gets output. So it's got 1, 2, 3, it's got 400 things in there. Okay. So the thing I'm really interested in, though, is the average of those things. So if I try mean, I should get an error. Okay. And I don't get an error. That's interesting. That's very interesting. Okay. And the reason I should get an error is that L was a list and I applied a function that works for arrays. And apparently they've changed that with a version update. Okay. So we can go ahead and do that. And then I'm going to do the same thing for x in range of 1 comma 21. Do L dot append x, and then I'm going to tell it to print the mean of that L. And maybe I should have put some actual explanations in there as well. But anyway, I got the 13.825 and then the 10.5. So this we've gone through and we've done all the possibilities and given the same weight to each one of them. Maybe here for the printout, this I should say mean with advantage. And then I should say standard mean. And so then if you got the printouts there, if you want to subtract the difference, then you'll find out that the difference between them is about 3.325. That 325, I don't know is any really significant number or something. But that was something that I might do in order to figure out what's going on with like a role-playing game that I'm doing, you know, on Roll20 or something like that. There was a similar thing a few years ago with a different game where I discovered what the difference between two things were in order to take, yeah, you don't need to know. I'm just saying that this sort of thing with writing little programs to try to figure out something is something that a lot of us just do as a matter of course when we're just trying to figure something out. So it's kind of neat to be able to do that just like that. And notice that I did it without really, I hate to say it, without knowing what I was doing, because I went and looked up stuff. And I've been doing this programming for years, but still yet I have to go look up stuff because I'm getting old and I can't remember it. Y'all have fresh young minds and you'll remember everything the first time you see it. Right? Right. Okay. So anyway, just an example to give you all an idea what kinds of things go on with this. All right. See you in class.